Okay. So let's get started. Before I get started, let's finish the stupid questions first. Does anyone in this room not know what cross-site scripting is? And I feel really stupid asking this. Sorry.
I don't, so I'm going to
Okay. I assume everyone does. Great. So my talk is on CSP analysis or content security policy. Anyone knows what it is? Content security policy? Okay, we'll cover that. So short introduction to, yeah, it works perfect to myself. My name is Frederic, I'm 24 and I'm from Munich. I work as an information security officer at Chip Digital. Some of you may know the site chip.de, it's mostly German. You can find all the examples on the source code of what I'm showing you here on #security.com/CSP. So if you want to check that out, please do so. And you can ask me questions anytime later or on Twitter at #security. Okay, so content security policy is basically an HTTP header. So if you request a site, you get a response from the server, and the server sends in the response sends you an HTTP header that says, example here, defcon.org, they have CSP enabled, and it's a content security policy default source self, which tells your browser you're allowed to load sources like JavaScript files, like style sheets, images, stuff like that, only from our server. They could specify from facebook.com or from wherever you want, but basically it's a whitelist. So the goal is cross-site scripting mitigation. So you can't just specify from eval.com / give me all your cookies.js. You can't include it if it's not here in the CSP. So obviously that's a nice thought, but it's not enough to mitigate cross-site scripting, just whitelisting sources, because if you have a cross-site scripting vulnerability, you could just add your own code in line. So what CSP does besides whitelisting sources is it blocks all inline JavaScript. So if you enable CSP on your site, it will probably not work anymore. I don't know, I guess a lot of you guys have a website that uses JavaScript, and probably not everything has been moved to JavaScript files and included, but sometimes there's just the typical script tags and then JavaScript in between, right in the .php or .html file. So this won't work with a CSP enabled. Other stuff that doesn't work, to make it work, as I said, you need to move it to a script file and include it like this. Other things that won't work is all eval functions are blocked. Eval is evil. Everyone should know that here. Don't use it. If you have CSP enabled, you could enable it on purpose. That's like opening all ports on a firewall. Kind of destroys the purpose of CSP. And another thing which most people, interestingly enough, sorry about that, don't know, var my function equals new function. That kind of declaring function in JavaScript doesn't work as well. It's blocked by CSP and you can't enable it. The reason why most people don't know this is because most people actually don't take a look at the request for comment, but they just go for blog posts, and it's not mentioned in most of the blog posts. So you might run into problems with that. Okay. Yet another thing that is blocked by CSP, and you can enable that as well, is inline CSS. So if you have anywhere on your site something like this, an headline one tag with a inline cascading style sheets like font color equals red. This is a basic cross-site scripting example. We have an unsanitized user variable and we can just add anything after Bob. And what I did here is I added the header one line with a style font color equals red, and as you can see, the header defaced is added, but it's still green because by the CSP, of course, HTML is not blocked. That would be disastrous, but CSS is blocked. Okay. You can see all the violations to your content security policy in your browser, which doesn't help you that much if a user comes to your page and browses it and stumbles across a CSP violation. For that, you can set up actually a report URI where all these reports from all users are sent to, and you have detailed reports in a log, which is kind of nice. It's supported by almost all browsers. Yeah, guessed it. Not Internet Explorer. These are the only guys who haven't implemented it yet, at least not fully. They have some features, but it's very experimental and not really supported by EE. Actually, I tested it with IE 11. Doesn't work. So they're still behind there. Okay, so the question, what is CSP? It's frustrating. It's really frustrating to implement it. You're really gonna have a hard time doing it, and if you do, please do your research first, otherwise you will break your site and angry people will be at your desk, definitely. So the question I want to answer here, is it worth it? If it's frustrating, do we really want to put that much time and effort into it? For that, I want to take a look if it actually does what it says it does. So I gathered all the information I could find on attacks on CSP and tried them each one by one, and let's take a look at that. So we have injecting JavaScript, of course, encoding JavaScript, of course. That's always a way to try to bypass stuff by encoding it. We have injecting into server-side files. If we can inject into the files that are on the server, most content security policies state that our own server is fine. Of course, why wouldn't they? So if you can inject into those files, then you're in the clear. If you can upload malicious files, of course, that's another great way to do it. Or if you can just manipulate the CSP header itself. Okay, so first up, this is actually interesting because we're not encoding the JavaScript to bypass the CSP. So in order to hide that we're using JavaScript, we're just encoding it so we can put it in the URL field without breaking anything. And the meta tag is an HTTP tag and is therefore not blocked because CSP can't block HTML. HTML. So what we do here is HTTP equiv refresh. We're telling the browser of our victim to refresh the page. Not any page. We tell it refresh the page base 64, and that's our JavaScript base 64 encoded. And what the victim's browser will do is it will take the base 64 string, decode it, and execute it. So we're not on the site with the cross-site scripting anymore, but we're still able to execute JavaScript in the victim's browser, which is at least something. Okay, so that's the most basic attack. Another attack, of course, is trying to inject into the JavaScript files themselves. So if we have to move everything from inside JavaScript to out of line, or inline JavaScript to out of line JavaScript, how can we inject directly into these documents? So I tried some stuff. I tried eval, which is blocked, but I tried it anyway. I tried var my function equals new function, which is how I stumbled across that this is blocked. And I tried, with the help of a colleague of mine, parent node insert. This actually worked. I'm not going to show it here because it's just a bunch of code and it's not that interesting. As I said, I've put all of the content, all of the code examples online. You can check that out if you want. It's really, really awful code. So if you shouldn't stumble across this. So the last example, you shouldn't stumble across this type of vulnerability in the wild, because we really put a lot of effort into making this vulnerable enough for us to bypass CSP. So this was all on purpose, and it still took us a lot of time. If you do, however, if you take a look at it and if you find it somewhere in the wild, please tell me, because if it's out there, I want to see it. Let's hope not. Okay. So another server-side injection is JSON, because JSON, much more obviously, it's used for storing data and for reading data from it. So this is a basic PHP commenting system. It is vulnerable. I made it a bit more vulnerable, not because I needed to bypass CSP, but because it's more convenient that way. I don't have to think about encoding stuff. It's just as an easy example. So you can just type in your comment, post it, and it's stored in the JSON file. And what the JSON file looks like is the first line. These are 2 comments in the JSON file. So you basically, I think I have a laser pointer here, you have your text field and then first comment, which is here, and then you have the second comment. And what we want to do is we want to close the JSON with a square bracket, add our JavaScript, and then open a new for further comments. What this does is it gives us valid JavaScript and valid JSON, so nothing breaks. If we just use this one, so if you, the gray highlighted area, if we just post this as it is, JSON will, when JSON encode is called, will encode it, and what you get essentially is a comment like this, but you've not broken it because it will escape all double ticks. So it's not going to work if you try to execute it. What we can do is UTF-7 encoded, and I actually never worked with UTF-7 before this, so that was something new for me. What you get is the exact same payload is now this string, and if you take a look at it, there are no double quotes, no double ticks in there. Double quotes, right? So it's not escaped, so we can't just inject it, and this is the exact same string as will be stored in the JSON file, so it's not been altered. So the first three dots are just the first two comments. I've stripped them away for better readability. But this is exactly what we get if we take the whole JSON file and UTF-7 decode it. So everything that's been stored in the JSON file before and is decoded UTF-7 won't change. So it's still the same thing. So that works quite well. If we include it via the script tag source equals and then our comments.json file, and then type equals application/JavaScript, what Chrome will tell us is you can't execute JSON files as JavaScript. It's not going to work because you have strict MIME type checking enabled, and that's not allowed. So what Firefox says is this. So that's quite interesting. I had to tinker a bit with it. Actually, Firefox gives you this response only on Firefox 4.01 and below. The reason for this is Mozilla stripped all UTF-7 support from Firefox 5 and above to be HTML5 compliant. It still tries to execute the JSON though. It just can't read it. Okay, so that brought me to another idea. If it takes anything you give it, why not try to upload that image? And there are a lot of vulnerabilities out there that think you're uploading an image because it's called .jpeg. So what else could it possibly be than an image, right? So this is a really, really basic example. I'm sure you guys can think of a lot better ways to inject code into images, but this for simplicity's sake. We have a file called eval.jpg. Actually, it's a text file with alert1 in it. And suppose we can upload it to the server, it's theoretically, of course, then we can just tell Firefox, if our victim uses Firefox, of course, otherwise it will break, to load this as a JavaScript file, and it will happily execute it. I tested it on Firefox 28, no problem. So this is still a possible attack. Okay, let's get to the last part. Who here knows what CRLF injection or carriage return line feed injection is? Okay, thank you. Basically, what you have is you have a new line. Thanks. And it's the characters percentage 0D, percentage 0A, which tells this is the end of the line, and now comes a new line. What we do, the code above is basically a PHP redirect page. So all it does is it takes the URL parameter and tries to redirect it to this source. And what you can do is you can call the site. I call it reader.php and URL equals site. This is our site with the cross-site scripting on it. You can add the cross-site scripting parameter if you can add them in the URL. And then just percentage 0D, percentage 0A, and don't put a line break in there. It's just for better readability, because otherwise the line would be too long. This is actually one line. Add your header option, which you want to add to the response from the server, like content security policy equals script source unsafe inline. We're just allowing inline JavaScript to be executed. So we're telling the CSP allow inline JavaScript, which is, as I said before, much like the allow eval function, bad. Never do it on purpose. Depends on the side you're on. Right. So what we do is we add 2 CRLFs at the end and tell the browser header end. Everything that comes now, just forget about it. This is the end of our header. It works on certain machines depending on the PHP version you have installed, because PHP actually fixed that problem. It still works even though PHP fixed it in some versions of Internet Explorer, but I don't tested them because Internet Explorer doesn't support CSP in the first place, so why bother? There wouldn't be any gain of it. So it still works, but aside from PHP having that vulnerability fixed, it's still a uncommon vulnerability. So this is just an example which has been fixed in the meantime. But there are still CRLF injection vulnerabilities out there, and if you stumble across one and there is a CSP in place, you could use this kind of attack to bypass CSP. Which brings me to the end of my talk. Does it work? And for me, CSP does definitely work. That looks strange. Because almost all of the attacks, if they still work, rely on other vulnerabilities to be in place. So you have the CRLF vulnerability that needs to be in place. You have the file upload vulnerability that has to be in place in order to bypass CSP. So if you have a secure site and only cross-site scripting on the side, yeah, secure site and cross-site scripting in the same sentence, then it's not going to work, except for the meta tag, but there's nothing CSP can do about that because it can't block the HTML meta tag. And once the refresh is done, it's not on the site, and you're not on the site anymore that's protected by CSP. So that's kind of a way around it. Okay, so the other question is it worth the hassle? And that's really for everyone else to figure out. I can't tell you yes or no. For me, it's definitely worth the hassle. I know how much work it is, and I know how much of a pain it can be. But if you take the time and if you get the resources, of course, for doing so, it can help you, because it not only blocks cross-site scripting attacks and gives you the time to fix them, it also, if someone stumbles across it by accident and doesn't even realize it, you get a report and you know that there's a cross-site scripting vulnerability and you can fix it. So for me, it's worth it. Okay, so that was my talk. As I said, you can find all the source code and the examples along with detailed explanations on #security.com/CSP. You can ask me questions now, later, or on Twitter at #security. I want to thank my mentor Dave for helping me, and also a colleague of mine who isn't here today, Scott, for helping me with the JavaScript, the evil JavaScript. And thank you all for listening and for having me.